So we're going to do a quick review on linear inequalities, and let's start by reviewing open and closed circles. So number one, we have x is less than or equal to -2. You can label our number lines, -2, so -2, -1, 0, and it says x could be any number that is less than or equal to -2. So we know that x could be -2, or it could be any number less than -2, so that could be -2.1, -2.4, etc. So I'm going to shade all of this. That includes all of the decimals less than -2. And then same thing on number 2, x can be a number that is greater than 9, so starting with 9, 10, 11, 8, etc. Now x can only be a number that is more than 9, so we know that x cannot be 9. We're not going to include 9, open circle. And we're going to shade in everything greater than 9, so that includes 9.1, 9.2, etc. I want you all to be careful about the direction of the arrows, because sometimes students always say that I think remember which way to shade by remembering whether the arrow points to the left or whether the arrow points to the right. And that's not necessarily always true, depending on which side the x is on. So when you read your inequality, you always start reading where the x is. So for number 3, we read it as x is less than -7. So open circle at -7, and x has to be less than -7. You shade to the left. And then for number 4, x is greater than or equal to -1. So -1, 0, 1. Close circle at -1 because x could be equal to -1. And then we want x to be greater than or equal to -1, so we shade to the right. Compound inequality has two inequalities combined together. So if we look at this line graph, we know that x in this case can be any number between 1 and 7. So one way in which we can write this is we can say x has to be greater than or equal to 1, and x has to be less than or equal to 7. And because it has to satisfy both conditions, we can combine it into a compound inequality that says x has to be between 1 and 7, including 1, including 7, right? Whereas in number 6, x could be a number that is less than -6, or x has to be a number that is greater than 8. So it doesn't make sense for us to combine it here because x cannot be a number that is less than -6 and greater than 8. So it's an or statement in this case when it's going in either directions, both directions. Okay, when you're solving inequalities, you solve it just like how you would solve a regular equation, except that when you multiply or divide both sides by a negative number, remember to flip the inequality. Flip the inequality sign. So in number 1, we're going to add 6. -3y is less than 9, and then we're going to divide by -3, and because I'm dividing both sides by a negative number, remember to flip the inequality symbol. So y is greater than -3. So we can go ahead and graph this here. And then go ahead and try the next one. And I'm just going to do it, so you could pause the video and try it yourself first and then go back and check to see if you did it right. So one more way in which we can write the solution instead of represent it as an inequality is something called set builder notation, which is something that you'll see in higher level math courses like pre-calc or calc. It's just another way to write your answer. And set builder notation utilize something called these curly braces that looks like this. They're curly brackets. These brackets represent a set of something. So a set of numbers, a set of apples, a set of something. So if the numbers 1, 2, 3, 4, etc. are in there, that will be the set of natural numbers. Okay, so this means my solution is the set of all values, all real numbers y, such that this little line is like a divider that separates your solution from the condition of your solution. So this reads, my solution is the set of all real numbers y, such that y has to be greater than -3. And then in the set builder notation, for the second one, my solution is the set of all real numbers x, such that x has to be less than or equal to 6. So it kind of separates your solution with the condition of your solution. And that explains it right here. So when you have a set, the values are inside your set are called elements. Okay, and then in this case we have the solution is the set of all real numbers x such that x is between 8 and 15, including 15. And then sometimes you will see it like this. And then that little e just means that is an element of, so that just means x is a real number. Okay, go ahead and try 3 and 4 and put your answer in set builder notation. Remember, if you multiply or divide both sides by a negative number to flip the inequality. So you can pause the video and then skip ahead in a little bit to see if you got it right. And then if you did, then you can move on, and if not, then go back and watch these last few minutes. here we go. So for number 3, your solution should be x is, my solution is the set of all real numbers x such that x has to be less than negative 1/3. And for number 4, your solution is the set of all real numbers y such that y has to be less than or equal to negative 1/3. So when you are graphing it, remember that each tick mark does not have to represent 1. You can space it out. Okay, and then the final way of writing your solution, instead of just inequality and set builder notation, there's another notation called interval notation. And in interval notation, we use parentheses that represents open or not including, and close brackets that means closed or including. And then we also have these two symbols, the infinity and the negative infinity symbol, which represents a number that gets progressively larger. So it's not a number that you can do operations with. So in this case, looking at the number line as an inequality, we would say that x, the solution would be x has to be less than or equal to 1. And to represent that in interval notation, we would say that what could x be? X could go from negative infinity, not including negative infinity, all the way up to 1, including 1. So the value for x could be anywhere between negative infinity and 1. And then if there are two parts, so down here, because I have an OR statement, we're going to use the union symbol that represents OR. So in an inequality, our solution is going to be x could be less than 3, or x is greater than or equal to 6. Okay, so then in interval notation, we would say that, well, what could x be? X could go from negative infinity to 3, not including either, so open parentheses, or using the union symbol, x could be anywhere from 6, including 6, to positive infinity, not including positive infinity, since we can't include infinity. So just another way to represent the answer. So go ahead and try number 5 and number 6. Try number 5 and graph your solutions, because it's a compound inequality. Graph your solutions on the same number line and see if you can represent your solution in set builder notation and interval notation. Remember to flip the inequality because we're dividing by a negative number. Okay, so that's one solution. Then on the right, we're going to subtract 1 and divide by negative 2. Again, I have to flip the inequality. And then we're going to go ahead and graph it. So here is negative 2, negative 1, 0, 1, 2. Open circle at 1, shading to the right. And open circle at negative 2, shading to the left. In set builder notation, we say that our solution is the set of all real numbers x, such that x is greater than 1, or x is less than negative 2. In interval notation, we say x could range from negative infinity to negative 2, not including either, or x could range from 1 to infinity, not including either. And then when you have a compound inequality that is an AND statement, sometimes it's combined. So basically what this is, it's basically negative 3 is less than or equal to 3x minus 9, and 3x minus 9 is less than or equal to 12, and they just combine it into 1. But you could separate it and solve it separately if you want, or you could just solve it together, as long as what you do to one side now, you do it to all three, the left, middle, and right. So your goal is to get the x by itself in the middle. So we're going to go ahead and add 9 to both sides, all three of them. And then we're going to divide by 3. That should not have an x up there, just 6. So we know that x is greater than or equal to 2 and less than or equal to 7. And when we graph it, close circles and everything in between. Your solution in set builder notation is the set of all real numbers x such that x is between 2 and 7. And in interval notation, x could be anywhere between 2, including 2, and 7, including 7. So in interval notation, open parentheses means not including, and close brackets means including. So as a final summarizer, let's see if we can write these inequalities in inequality, set builder notation, and interval notation. So I want you to pause and try it by yourself, and then go back and check. In interval notation, the first problem is x can go from 2 to infinity, not including 2, not including infinity. And the second one, from negative infinity all the way up to 2, including 2. Okay, and then the last one, because we have two parts, we have to use the union symbol. So from negative 1 to 1, including both, or not including both. And that's the bell. So from negative 1 to 1, not including both, or from 3 to 4, including both. Alright, so whatever we don't understand or questions, we'll look at next class.